All right, we're back and we're taking a look at a very special limit today, the limit of what we call the difference quotient here. This expression should look kind of familiar to you. Hopefully it is, because we've played around with this before, just had you set it up and simplify it back in earlier chapters when we did the binomial theorem for expanding binomials. We did this, and now we're going to be taking the limit of it as h approaches 0. And when we had done this, I said, eventually this is going to mean something very important. And that's not today where it's going to click, but that is going to happen very soon in the next few days. But we're just going to take a little further so that when we need it, when it needs to make sense, we're good with the algebra portion of it. So, if you'll recall, setting up this expression, the part that required maybe the most work, or the part to take your time with, was doing this part of it, the f of x plus h portion. So just keep in mind that to do f of anything, right, f of x, if I ask you to do f of 17, what are you going to do? You're going to plug 17 in for x. Or I have you do f of anything for this particular function, you're going to do 5 times that something squared plus 3 times that something minus 8. So we're going to do f of x plus h. Now this is just the f of x plus h portion of this. So plug x plus h, plug x plus h. And now let's take some time and simplify that algebra. We're going to, order of operations, be good here. We're going to square this binomial, then distribute 5. If you can do that in your head, that's fine. I think I'll square it right here. That'll be x squared plus 2xh plus h squared. And then when you distribute that 5, you will get 5x squared plus 10xh plus 5h squared. From doing this part of it, plus 3 times the quantity x plus h, you will get plus 3x plus 3h. And then you'll have minus 8 on the end of it. All right, all of that is the f of x plus h part. So let's just take our time. We'll forget about the limit for right now. Let's take our time. The f of x plus h minus the f of x. Now f of x plus h was all of this that we just got. So I'm going to try to be neat here. I don't want to leave anything out. That's 5x squared plus 10xh plus 5h squared plus 3x plus 3h minus 8. And then I'm doing minus f of x. And f of x was the original function. Just be careful you're subtracting that whole function, so you've got to wrap parentheses around it and distribute that negative to subtract the entire thing. And that's all divided by h. And then I'm going to take the limit of this whole thing as h approaches 0. And maybe it bears pointing out that for this, regardless of the function you're using, when you have this set up, your idea of evaluating a limit is, let me try to substitute 0 for h. And if you substitute 0 for h, you will get 0 in the bottom, and in the top, when you substitute 0, you'll get f of x minus f of x, which will be 0 over 0, indeterminate form, which is why we're doing all this algebra, to hopefully be able to cancel that h from the denominator so that I can evaluate the limit as h approaches 0. Because you can't do it as long as that h is in the bottom. So if you kind of remember how these go, I guess I'll just slap that limit as h approaches 0 out in front. If you remember how these go, if you've done them right, the original function here should always cancel out. And so that's minus 5x squared minus 3x plus 8. And when you combine it with some of the like terms you have here, 5x squared minus 5x squared cancels. 3x, which was right there, minus 3x cancels. Negative 8 plus 8. The original function cancels, and it's easy to leave out a term here, so just take your time. We have 10xh left over, plus 5h squared, plus a 3h there, and it's all divided by h. And now what does that allow you to do? If the original function has completely canceled out, what should be the case is that every term has at least one h, allowing you to factor h out so that you can cancel it from the denominator. Or in other words, just divide each term by h. Take h away, take one h away from each thing. So when I do that, when I take an h away from each of these terms to factor it out, then that allows me to cancel it. And now here's what I'm really left with. If I'm trying to show every step because this is the first example we're doing, that now you're left with that. Just remember, you haven't yet taken the limit until you've substituted 0 for h. And when you substitute 0 for h, not for x, because you got two variables going on here, so just pay attention to that. Substitute 0 for h, that part's going to drop out, and you're left with 10x plus 3. That is the answer. Right now, it doesn't mean a whole lot to you, if anything. It's just a little algebra manipulation. And that's good enough for right now. So now we're doing it with some other types of functions, some square roots, some fractions. But I'm still going to set up this same classic difference quotient, as we call it. And this one is actually maybe even a little nicer here, that just the f of x plus h part. Remember, don't get tripped up by that. If I were to ask you to do f of 5, what would you do? You'd plug 5 right there for x, right? And then you'd have plus 7, and it'd all be on the inside of a square root. So f of x plus h is just putting x plus h plus 7 all on the inside of that square root. So the limit we are trying to do, the limit as h approaches 0 of f of x plus h, which is this square root of x plus h plus 7, all under that square root, minus f of x minus the original square root of x plus 7, and it's all over h. The denominator is always just regular old h, nothing changing there. And now you're here at this point, and this should look like a familiar limit from what we've been doing the last day or two. You can't substitute 0 for h because you get indeterminate form, no problem. How do we handle these radical expressions? We're going to rationalize the numerator by multiplying by the conjugate, which would be root x plus h plus 7 plus root x plus 7. Remember, always the opposite sign of whatever is in there. And don't forget to multiply the denominator by that as well. Sometimes people do. That's actually a common mistake because they're in a hurry to get on to the next part of it. But don't be sloppy. And so we have the limit as h approaches 0. And I mean, really, you could evaluate the whole thing if you wanted and simplify and get it down to here and then throw the limit in at the very end. I'm just sort of keeping it out in front as I do all my simplifying. In the denominator, I've got h times that square root of x plus h plus 7 plus root x plus 7. And in the top, those conjugates, x plus h plus 7 and negative root x plus 7 times positive root x plus 7 is going to give you negative x plus 7, the quantity x plus 7. So you have to distribute that negative. Watch out for that. Easy enough, though. That's just negative x minus 7. And when you combine your like terms, x minus x, 7 minus 7, and notice what you're left with is h. And that should, again, be the case. Even though it was not a polynomial, your goal is to try to cancel that h from the denominator. And that's all I'm left with here. So you can cancel that h. Just be careful, it leaves you with a 1 up top. And now that means as soon as that h is gone, now you are free to evaluate that limit and plug 0 in for h, because you won't get it being undefined anymore. So now I'm going to substitute 0 for h. The limit notation is gone when I do that. When you put 0 in for h, which is right here, you'll just get root x plus 7 plus root x plus 7. And you will get 1 over 2 root x plus 7. Now here is where I'm going to tell you this, that you can stop right here if you like. We may have said this earlier in the year, but if your answer is a number, 1 over root 2, 2 over root 3, I still expect you to rationalize it to make it that familiar form. But if your answer is an algebraic expression or a function, if you don't want to rationalize the denominator, you don't have to. You can leave it like that. If you do want to rationalize, that's fine. It'll be root x plus 7 over 2 x plus 14. But we're just going to leave it like that. You're going to see all kinds of little things, next year in calculus. You're just concerned with bigger issues rather than wasting time, manipulating that a lot. So I'm good right there. And last one, just one more for good measure. It wouldn't be this difference quotient day if we didn't do a complex fraction, because now our f of x plus h, our f of x is 2 over x minus 5. So again, just don't forget, plugging x plus h into this function means you're putting it down here, 2 over x plus h minus 5. So your f of x plus h minus f of x is going to look like this. Limit as h, you know what? How about this? We won't write that every step. We'll just deal with the expression, simplify it, and then we'll take the limit at the end. So our f of x plus h is 2 over x plus h minus 5. That's f of x plus h minus the f of x, so minus the original function, and it's all over h. Again, you wouldn't be able to evaluate this limit. You'll get indeterminate form. How do we handle complex fractions? I like to multiply by the LCD. If you like, you can make common denominators again with the two fractions in the numerator. Common denominators, put those together and then multiply them by 1 over h to make a nice fraction. It's about the same amount of work. I'm going to multiply this by that denominator and that denominator to cancel. Just got to do it to the bottom of the overall fraction as well. Hopefully this is really not that crazy of a leap algebraically for you at this point. But our denominator now looks like that, and in the numerator here, just be careful when you distribute this to each of these, that's going to cancel, so you'll be left with 2 times just x minus 5, because the x plus h minus 5 will cancel. So you have 2 times x minus 5 minus, and this one, you'll have 2. This one, the x minus 5 cancels, so you'll have this x plus h minus 5 times that 2. And again, don't make silly algebra. Don't go canceling that. Don't go canceling that. This is not in factored form. You've got to distribute and combine and then try to refactor. So 2x minus 10 minus 2x minus 2h plus 10. When you do all your distributing, combine your like terms. And if you can do some of this in your head, that's okay. I'm trying to show every step. Certainly some shortcuts can be taken, but don't take too many because you'll make silly mistakes. Negative 10 plus 10. So again, what we're left with is negative 2h, meaning we can cancel that h, and that is what you wanted to happen. You wanted that h to cancel algebraically with these problems, even though the original problem looked a little different. So here's what we're left with after that h cancels. We have negative 2 over x plus h minus 5 times x minus 5. Just remember, we haven't been writing it the whole time, but we still haven't evaluated the limit as h approaches 0. So now is the time to do that. You've simplified the expression, but now let's take the limit of that simplified expression, plug 0 in for h, and you'll have x minus 5 after that becomes 0 times the other x minus 5, which you could leave. You could FOIL it, but probably your teacher's going to leave it like that, negative 2 over x minus 5 squared. And there we go, 3 classic difference quotient problems. So hopefully you feel good. Let me know if you're not.